Okay, so we are after the top of the hour, so let's get started. So welcome everyone. This is the Redfish 2023.1 webinar. My name is Mike Ranieri. I'm with Dell Technologies, and I'm one of the co-chairs of the Redfish Forum. We also have Jeff on the line here. So Jeff, please say hi.
Hi, I'm Jeff Otter from Hewlett Packard Enterprise, and I'm the other co-chair of the Redfish Forum.
Great, thank you. All right, as a note, this webinar is being recorded, and once it's complete, we will be posting the recording on DMTF's YouTube channel. And so right now we have a polling question. We'll actually do two polling questions here, so we'll give a minute or two for folks to answer. All right, first question: what's your interest in Redfish? Yeah, I think that should be enough time for folks to respond to the first question. So let's take a look at the results. Okay, so we actually got a good mix here, and actually we have an additional joker this time. So thinking this is a fishing show. Good. No, I like to see a good group of folks here. All right, so let's go to the next polling question. All right, so what's your familiarity with Redfish? So are you new to the standard? Are you actually using it today to perform management tasks? Are you writing any Redfish enabled code, or do you work for a member company? So we'll give it about 10 more seconds for folks to answer. Okay, that should be good. All right, so we actually got quite a few new folks on board. So 6 people responding, just getting started. Some folks are part of the DMTF already, so great. Always happy to help other folks out. Right. So we'll begin by going into the release material for 2023.1. And so, like with most releases, we have several artifacts that we publish at a regular cadence. This is our first publication for 2023. We've released Redfish specification version 1.18. And we added in some new terminology for how we can annotate Redfish URI segments to better describe when URIs don't actually match the property naming path. So if you think about how URIs in Redfish are structured, most URIs follow the pattern where if you trace the property names down into resources, you see those property names in URI segments. But there are a few exceptions from the early days of Redfish that don't accurately capture that methodology, and we want to highlight those exceptions with a new schema annotation to make it clear for a reader why there's a divergence and when to expect that divergence. We've also had a few clarifications to the spec with our 1.17.1 errata release, showing a better example for msearch responses for SSDP queries, having some authentication clarification. So when a service can reject unauthenticated resources if credentials are not valid, giving some guidance around how action responses are formed just to better match the terminology we have in the schemas, and also clarifying the access control allow origin header to be optional. It's not mandatory. We've also updated our RedPath specification. For folks who don't know, RedPath is a client-side query language for how to present itself to an end user or for a consuming application. So you can build up a very detailed structured request for inspecting a Redfish service. We added in some new syntax to allow for binary comparisons between, Boolean comparisons between different properties. We also released our new version of the schema bundle. DSP 8010 contains all the relevant schemas. We have several new schemas, which we'll go into more details about in the following slides. The big material in this release has been supporting cooling unit devices, so getting into more of the infrastructure space for rack mount cooling equipment. We also have some relatively important updates to drives and storage controllers, so showing their metrics and having some new actions associated with those, and that was part of a request from SMEA. We also have a new version of the message registry bundle. DSP 8011 contains all those registries. We have several new message registries we have environmental types of messages. So when you have cooling events, or rather when you have thermal events or fan related events, there's a power message registry now for all your power equipment and internal power componentry. There's also a platform level message registry when platforms take exceptions or other types of critical errors. All of the material can be found at dmtf.org/standard/redfish. And now I'll hand it over to Jeff for walking through the new cooling distribution unit model.
Great, thanks, Mike. So the new support for cooling distribution units or cooling equipment in general builds on several years of work that extended the Redfish model into the data center infrastructure space. We started with some of the power equipment around power distribution units, and that laid a lot of groundwork for how that types of equipment will be modeled. Things like the sensor and control infrastructure, so that we had a general purpose data model that would allow for normalized views of these things across a lot of different equipment types. The reason that what drove us into these areas is that as equipment has evolved to incorporate web GUIs or just Ethernet based connectivity in general, it became clear that if you've got a web GUI, a REST-based management interface is kind of one of the things that you would need to drive a web GUI, number one, and number two, well, it's exactly what folks want to have for programmatic control from other applications. So the leverage then became that the care and feeding of any of those web managed or web-based management devices is very common with what we had already done in Redfish. That is, everybody needs accounts and eventing and ways to update firmware, discovery, et cetera, et cetera. It's all the kind of what we call housekeeping functions that would be common with any of these managed devices, whether it was a server, a storage device, or a PDU or a CDU. So that leverage of being able to use both the standardized protocol as well as the tooling ecosystem that's building up for Redfish meant that a lot of that work is already being done in the industry, then it can just be leveraged. So all that said, the release in 2023.1 provides support for liquid cooling systems. This model has been worked extensively with input from a lot of vendors, both within the DMTF and also in conjunction with a lot of feedback from the Open Compute Project's liquid cooling sub-project and the management groups underneath that. We've worked on this to get what is hopefully a good generalized model for any type of liquid cooling, or really any kind of cooling infrastructure component. But our coverage expected in this first release is we focused in terms of mockups and the viability of the first release was to look at rack-based or rack-mounted cooling distribution units, or at least those types of units intended to cool a rack or a set of racks. Also immersion cooling units or immersion systems, as those are also a hot topic right now. And then also heat exchanging units, either freestanding or part of a CDU, or as a or is like a rear door or an in-rack heat exchanger. So other types of equipment, should be able to be supported if they need to have new categories. This is one of the things about Redfish is just by the very nature of JSON and REST interfaces, it's easy for us to add more properties and more collections of different types of equipment. So we expect that this can be leveraged for any kind of cooling gear. And if we need to add more, it's easy to do, and feedback is absolutely welcome. So the way that this was implemented is just as we did with the power equipment. We made a resource off of the service route. This one's called thermal equipment, just to be general purpose on this. So don't know if we'll get heating units, but we just called it all thermal. So that's mainly there to provide as a jump point and as a way for you to discover that this particular Redfish interface has equipment in this category. So it's trying to be an easy way for you to discover and filter, when there's a number of Redfish interfaces available in the data center. Off of thermal equipment then is our individual collections of cooling unit schemas. And so cooling unit is the generic term for a functional piece of cooling equipment. And that's where the bulk of the equipment details will show up for each piece of equipment in the in that infrastructure. And of course, as with everything else in Redfish, the models all support, one or one-to-many. So, you can have a gateway device, for instance, that would manage, a whole rack full, or excuse me, a whole row of individual CDUs that maybe are daisy chained or connected via Modbus or whatnot to one device that surfaces the web interface. All of that is supported. So you can have 5 cooling units all managed from a single IP address. That's all just part of normal Redfish modeling semantics. So the cooling unit resource that provides the bulk of the details about the equipment. So make, model, serial number, capabilities, and then all of the hyperlinks to all of the subsystems. And so we have a lot of subsystem schemas for things like a pump, a reservoir, a filter, and so forth. So those major subsystems have their own details. And again, of course, those are collections. So, you can have multiple filters, multiple reservoirs, and so forth. The other pieces off of cooling unit are the links to a cooling loop. So this is the cooling loop itself describes, the actual piping or the connectivity among things in that chain. So the cooling loop is probably just a software construct, because obviously most pipes don't have a web GUI attached to them, but this is a way for us to normalize the data model and to be able to show the connections between dissimilar types of gear and give them a way to give all those pointers, with the goal being that you can chase the links and the connections throughout the data center, from service to service. So, and we'll show a little bit of these details. The bulk of the quote unquote interesting data shows up in a resource called Coolant Connector. This is how you model the connection between a piece of a cooling equipment, or either on the producer or the consumer side, and other pieces of equipment, or a connection, out of one piece of equipment to a cooling loop, and then on to the next piece in the chain. So we modeled the coolant connector as really the point of both the physical connections to give you the links and the pathways to follow, but also to give the telemetry, since the measurement points are effectively at those connectors. It may not be part of the physical connector, but from a functional or logical standpoint, most folks are measuring pressure, temperature, and flow. Well, that happens at an intake or an outflow point. So those can all be described that way. The coolant connector allows you to model a pair of connectors as a single resource, which as we see when folks are getting data and trying to be efficient, I don't need to do do separate requests for the intake and the outflow of a pair of connectors, I can get all those measurements with with one operation. So one addition we made to the sensor model was the ability to have a delta value or a differential value. So there's that can now obviously those get surfaced in the data models for these coolant pieces, but generally speaking, we wanted to ensure that folks looking at the sensor model without any prior knowledge about the usage of that in in a cooling unit in particular, that the value you were seeing was actually a difference or a delta and not a number based on zero. So we didn't want folks to create graphs of temperature and see that that there were four values at 25 degrees and then and a value at 3 and then think that was a bad thing. Like nope, that's a delta value. So lastly, one of the critical subsystems in a cooling in a liquid cooling system is the leak detection and the leak detector sensors that go with that. So there is a separate resource that provides the ability to discover both the presence of these leak detection systems and their functional state and obviously if they've detected a leak. So this bubble diagram looks a little daunting, but it's we probably could put one more arrow on here that would have shown that it's not as bad as it looks. Starting up in the upper left corner there, the Redfish service route. So this is the /Redfish/v1. This is where all Redfish discovery operations start. And so under there, the thermal equipment. This is the new resource that's effectively the jump point for any type of equipment that's in this that's in this category. And so, as I said before, underneath that, there's a collection of cooling units specifically for cooling distribution units. And so there's that collection. In this model, we've got one instance, and that's rack CDU number 7. So that cooling unit resource then would have all the product information, make, model, serial number, and all the capabilities. And you can see that there is quite a number of links. Those arrows all leading out of that bubble, showing all the various subsystems that are part of that unit. So not going to go through all these individually, but you can see kind of on the top part of that is the leak detection subsystem, and then a collection of leak detector sensors. I'm sorry, I call them sensors. They are not they are not a sensor in the Redfish sense, because these are state pieces. So there is a specific leak detector schema defined because those have a specific a state value. They're not a numeric piece. So sorry, I don't want to confuse folks, but so we'll just call those leak detectors. And then in this example, there's there is a reservoir. There's reservoir number 1. There is a pump number 1, and this particular one has 2 filters called primary and secondary. Then circling around there are the other pieces. Some of these have been leveraged. So there's an environment metrics. That's to show things like the temperature and power consumption of the cooling unit itself. That's not the temperature of the water or the fluid. That's the temperature as measured at that location. So that can be used for other calculations or reporting, and other environmental conditions like humidity show up there as well. The bulk of the interesting data and the telemetry are in those coolant connector collections. They are separated into 2 collections by functionality, as most cooling equipment has a primary and a secondary side to them. With obviously the cooling business going on between those. So we do separate those out, and so each of those has a separate collection. And you can see in this particular one, we have a connection on the primary side coming in from the facility. So there's some external link there to another Redfish service that hopefully is managing the facility level infrastructure. And then on the secondary side, you see that there's a coolant connector that jumps over to a cooling loop that's serving what appears to be rack number 7. So and the cooling loops themselves are managed as separate entities under thermal equipment, as you can see. One other piece that's common with the Redfish model as we've grown the model and trying to be more consistent, this was a change we made and then backfit this into the power distribution models, and that is the physical containment of this equipment is all done through the Redfish chassis model. So this does appear at first glance to be some duplication of information, because the chassis has things like make, model, and serial number, and but it allows us to give for really one more resource, and it's a static resource, not very complicated to implement, but it does provide the physical containment within the chassis and the nesting that goes within that. So we want to make sure that that folks trying to map their data center and find out all of the equipment in a rack, that they should be able to traverse the rack and find all of the gear that's installed. And the way that is done is by looking at all the chassis resources. So so we want to make sure that all of this gear has both functional models, which is the cooling units in this case, but also the physical model, which is the chassis. And that is it's fine, Mike. So and this is an example, and so I just do want to mention at this point that we after we've completed this webinar, we do have a roundtable, and if folks want to talk at length about the new cooling models, we absolutely will engage in those discussions and get into details, since this is certainly a new area. So briefly, this is an example implementation, or well, at least a simple block diagram of one. So in this case, you see here we have in the yellow box a CDU. So there's the cooling unit, the model. That cooling unit has a connection down to the primary side, the cooling loop of the facility water system. So that gets modeled as a cooling loop and a coolant connection. And then the secondary side of that CDU, the output of that is the cooling loop for the rack. So that's the one on the right. So there are coolant connectors that then make a connection to that loop, and then a connection from the loop to a heat exchanger that's mounted inside this rack. So this is kind of a model of a rear door heat exchanger. So where there's a CDU that's actually providing the chilled liquid. The heat exchanger itself gets in this model gets modeled as a chassis, because it has a thermal subsystem with fans, and so that's done just as any other piece of equipment with internally managed components. So the fans are there; they all get monitored and controlled the same way that they would for a server chassis or anything else. There are some new sensors added to the ThermalMetrics resource underneath the thermal subsystem that allows the exposure of airflow and delta pressure sensors on the air side. So that's kind of how the heat exchanger works. The dotted arrow here in this diagram is just showing that one of the other common implementations of a heat exchanger at the rack level would be directly to chilled water system at the facility level. So no local cooling unit, just a direct connection to to an external cooling loop. So you can see that it would be one or the other of those things, either the CDU or the direct piece. And so you'll see then also that at the chassis level, this is why we want to have consistent physical model representations with chassis resources, because you can see that that whole box, everything is contained within a rack chassis instance, and so within that rack there would be 4 more chassis instances, one for the heat exchanger, and then in this case it's showing three server chassis. All right. So as Mike mentioned at the top, the other piece of new schemas and new coverage in the data model was for drives and storage controllers. So there are new DriveMetrics and StorageControllerMetrics resources. Those hang off of drive and storage controller respectively, and so that has the statistics details for health and error counts, mostly coming from other industry specs or commonly available statistics. Specifically for NVMe devices, there is an entire object, a sub-object that copies all of the smart log and health pages, and that's specifically for NVMe devices. Just want to make that clear that because the NVMe specs do define, give good interoperable definitions for those smart pages, which was not necessarily the case for rotational media. So those pieces are specific for NVMe. Under storage controller, there was also some new actions, and that's for handling namespace management on NVMe. So there's an attach and detach namespace action on the storage controller. And then lastly, and this is a kind of a pass-through operation, but it shows that with Redfish and all that, as I said, the infrastructure that Redfish provides, this is effectively a pass-through for security send and security receive actions to be able to send these security payloads defined by the is it the SPC5 spec, I believe is the name of the spec. So but these are not broken out. This is effectively, here's a payload and here's the protocol and the target to use, and that's there for setting up and onboarding secured storage devices and giving them their credentials and certificates and so forth. These are done as effectively opaque, blobs of data passed because the management infrastructure, meaning the BMC, the enclosure controller that's actually implementing the Redfish interface, it may not have the ability to encrypt or decrypt that information. So we've basically just allowed the conduit to pass through the secure data without the management controller having to know what is included in that payload. All right, moving on. So as Mike mentioned, we have 3 new message registries. This is some of these are long time coming, but it's we want to start building some critical mass on industry defined common messages for events and for logging. So we started with some basics in these, and they are, like I said, these are always easy to add more. So we try not to go too far. We set some patterns and some direction, and then please, if there are standardized messages that occur across multiple implementations and vendors, we would absolutely welcome those additions to be part of the standard. So the 3 new ones are what called the platform registry. This is that's a generic term trying not to be specific for servers or compute platforms, but it's effectively a small number of messages to gather, to give a common name for things like an operating system crash, or a memory or a critical CPU error, or any kind of processor fault. So in the server space, those are things like NMIs, machine check errors, and then OS crashes, blue screens, core dumps, so on and so forth. So a small number of messages that are providing some, they're fairly generic, but it's still, hey, an OS crash, and here is the ability to add a bunch of the data that comes along with those kinds of critical events. The power registry has messages regarding any kind of electrical fault or measurements. So violations of thresholds around over current, over voltage, and so forth. Also, the related types of power related delivery gear, so power supply failures, power supply insertions and removals, circuit trips, those kinds of things. So the intent is that if you're a client and you want to see anything regarding the power infrastructure of a data center, you could just go do event subscriptions for the power registry across every Redfish device, and you would get whether it was a power supply failure or a circuit fault or a under voltage or an overcurrent condition, that would be a way to do a very simple subscription and get all of those things, but not get all the other details of the day-to-days running of the data center. So same thing on the environmental side. So we use that term to instead of thermal, because it's more than just thermal management. It's kind of anything in the environment of a data center or or wherever the gear lives. So this can be again just over temperature conditions, high humidity, et cetera, et cetera. So a very similar style of those in both the environment and the power, and they follow a pattern that was set up with our sensor registry, a few releases back. And then and I'm running long, so resource event and base added a few new messages. The one in resource event was actually providing a standardized test message, just so that we had something defined for being able to test an event subscription, which is a new action that Michael will mention here in a minute. And then base added a few more things as we found there were some gaps in common handling for dealing with array patches. So there's those.
All right, so I'll step through the minor updates to the other schemas. So in account service, we had some new additions to the external account provider definition to have retrying timeout policies. We added OEM objects as requested for OEM extensions to in this case just to the TACAX Plus service. We added alternative names to subject and certificate as a way to just surface more certificate details when you're inspecting them without having to step into the raw certificate string itself. Within chassis, just work done to incorporate the additions made for the cooling distribution unit model. Within connection, allowing specification of CHAP and DH-CHAP types of connections to for remotely connected host to storage devices, and then also being able to assign a LUN to a volume potentially. Control, we added a new default set point property to indicate, what would happen to this control when you reset it to its default values. And so showing, okay, if you reset me, this is going to be my control set point. We also added a few new terms to control type as part of supporting the cooling distribution unit model, but also as to try to drive a commonality between what the industry uses in terms of terms for different types of controls and measurements and mapping that directly to the Redfish model. So being consistent with saying, when in this case we're moving away from just a generic pressure and specifically calling out pressure kilopascals. Within Drive, we added a firmware version and the new metrics properties. We also added a new operation type property to the overall operation structure to better drive a consistency in how you convey outstanding drive operations. Within Ethernet interface, we added affiliated interfaces as a way to map VLAN Ethernet interfaces back to physical interfaces and vice versa. Within event, we added CPR types of information and also being able to show diagnostic data directly out of an event, and so this better ties back to the new platform message construct that Jeff just described earlier. In event service, we added a new action called test event subscription, and that's really an easy button, zero parameter use case for testing out an event subscription with a pre-canned message. That way you don't have to build up a potentially large action request for the submit test event action, which we also did update to align with the event constructs with the fact that there's been a missing message severity parameter from that action. With the external account provider, same changes that we made in account service. This was done in the dedicated external account provider resource in case you have a dynamically growing list of external account providers. Facility, we added in hooks back to the cooling distribution unit model. For fan, we added a new property, fan diameter millimeter, to show physical constraints about the fan itself. Log entry, adding in that same CPR type of information to go along with the platform types of events. Within manager, adding in a new selected network port link, so that way if you have a manager where you can configure which port is in use, you can use this property to show which physical port is assigned to a particular interface on the manager. In-memory metrics added in capacity utilization percent. Within power supply metrics, adding in a new fan speeds property to better reflect the fact that power supplies may have multiple fans, and so deprecating the existing singular property in favor of the more robust one that accommodates newer designs. Within processor, adding management detected faults to throttle causes. So we've been listing out different reasons why a processor may be throttled. One thing that that escaped us at the time was the fact that a management entity could decide to throttle a processor because it has unknown data or insufficient data, and so it's taking a conservative estimate. So it's not necessarily there's a real power thermal issue, but the manager may say, based on my policy, I need to throttle because something is unknown. Within registered client, adding in context and subcontext fields as a way for users to leave behind information about when they register themselves with a service to say, I'm monitoring this piece of equipment, and here's some additional details about what I might be doing with it or how I want to tag information. Within the common location property, we added in part location context to help give more clues to a client about where this piece of equipment may exist. Within sensor, adding in some of the new units based on the new CDU model, and also trying to better align the sensor type terminology with how values are being conveyed in other areas. So again, going back to pressure as an example. So instead of saying just a generic pressure, trying to call out the units being used. So we have pressure. We already had pressure KPA to show kilopascals as a sensor reading, but there's still a use case for actually having it very granular down to the Pascal usage. We've also added in new ways to better reflect the threshold usage, so having disabled as part of the activation. We also added in hysteresis capabilities to sensors to show, how far below a threshold do I need to be before I can deassert a threshold event. And then adding reading basis in case if you have a reading that's not really zero based in the normal sense. What if your sensor is based on a known offset potentially? So that gets you back to the whole delta use case. Adding within service route, adding in thermal equipment to point to all the new cooling devices. Within storage, having adding in connections and to show any type of access policy that may be going on for a storage subsystem with remote hosts. Adding in a new auto volume create property to indicate what happens when new drives are inserted within a system. Maybe the system will create new volumes automatically. Adding links back to other storage subsystems for NVMe OF discovery purposes, and then also deprecating the storage groups property in favor of this new connections one for better consistency with fabric management. Within StorageController, adding in the new actions and metrics that were requested by SNIA that Jeff already went through, and thermal metrics, adding in new metrics that are associated with cooling equipment. So delta pressure, kilopascals, and airflow in cubic meters per minute. Within thermal subsystem, added coolant connectors. Within triggers, adding in the new hysteresis capabilities, and then within trusted components, adding in a TPM object to show TPM related information. Like with everything else that we do for each release cycle, we also produce new Schema and Registry guide documents. We have our Redfish data model specification, which is a human readable version of all the long descriptions from all the schema files. We have our resource and schema guide, which is the more end user type of view of the whole data model. We have a registry guide, which is built based on our registry contents. And then our property guide as just a simple dictionary of all the properties that we define in Redfish. And also as a reminder, we do have Redfish conformance tools available out there on GitHub. We have our protocol validator for doing all the protocol level types of testing. We have the Redfish service validator for validating all payloads in a service that conform to the respective schema definitions. And then our Redfish interop validator for testing a service against a Redfish interoperability profile. Okay, so we'll go to our last polling question. And we can also answer questions that may have come in during the webinar. So let's show the last polling question. So do you use any open source Redfish tools from DMTF? So we have a couple different tools available, class of tools. So we highlighted the conformance tools on the previous slide, but there are also libraries in which you can use to build applications. We also do end user tools like with Tacklebox and Redfish tool. We'll give another few more seconds to answer. Okay, that should be enough time for that. Oh, good. We got someone actually using libraries. Great. All righty. And then lastly, if you'd like to get involved, please go to dmtf.org/standard/redfish. You can get all of our specs, white papers. We also have a developer portal up at redfish.dmtf.org. We have a public-facing user forum. So if you have any questions, comments, requests, feel free to go to redfishforum.com. We also have the more formal DMTF feedback portal if you want to make submissions to the Redfish standard. Or you could join the Redfish Forum itself. So sign your company up and join in on the fun. So we also have a short survey to fill out. And that's the end of this webinar for this release cycle. So thank you everyone for attending. We have a roundtable coming up next. So there's a different Zoom call for that, but please fill out the survey and hopefully you will join the webinar. Join the roundtable in the end. Thank you for watching.